Hey everyone! So we are starting concept 16 today, and this concept is actually the beginning of a different section. We've just spent concepts 10 through 15 working on multiplying and dividing exponents on variables and multiplying and dividing radicals, and now we're going to be moving into adding and subtracting. Another name for that is really just called combining like terms, which is the title of concept 16, combining like terms. So we're going to start today with just a little bit of vocabulary. These are words that you've probably already seen before. We're going to just go through them quickly and identify what they are using a couple of examples. So our first word is an expression. We've been working with expressions this entire year, but especially in these last several concepts. An expression is just numbers and or variables in operations. The thing you don't see in an expression is an equal sign. So here we have two examples of expressions, but remember, an expression can also be really short. It could be something like just 2x or even just -3. It doesn't have to have all of these different things going on in it, but here is just a bigger example of one. Terms are the parts of an expression separated by plus and minus signs. So to count the terms in this example, we just look between the plus and minus signs. So here we have 5, and then -8x, and then 4y, and -1, and so on. So we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 terms in that first example. Like terms are two or more terms with the same variable raised to the same power. So they have to have the same letter and the same exponent on that letter. So let's start with the term -8x. Notice again how I brought that negative sign that's in front of it, it looks like a subtraction sign, which it is. But when you think of it as a separate term, it's -8x. Let's find all the other terms that are like with that. So the other like terms that go with it would be -x and 5x. Those are all like terms. Let's look at the next set. We're going to start with 4y. The other terms that are like 4y would be 3y. And finally, let's look at -6x squared. The other terms that are like that would be -9x squared. So those two are like terms because they have the same variable and the same exponent. Finally, we could actually look at the numbers that don't have a variable, and those would be like terms as well. And so 5 and -1 would also be like terms. A constant is a term with no variable. That's something you already knew. And so as the two we just looked at, 5 and -1 are the two constant terms in this example. And then finally, coefficient. That's a word we've talked a lot about this year. Coefficient is the number in front of a variable that's being multiplied by it, and every term has a coefficient. So first, let's identify all the coefficients of the x terms. We can actually look right here, since we have all the x terms listed, we could look at the coefficients there and find the numbers in the front. The coefficients would be -8, -1, and 5. Notice that middle term, it was -x, but there's an understood -1 in front of it. Now let's find the coefficients of our y terms, and we can look right here at these two terms. So our coefficients are just 4 and 3. And then the coefficients of our x squared terms would be -6 and -9. Now I mentioned earlier that all terms, every term has a coefficient. So even the constants have a coefficient. Remember how you can write any constant number like the number 7, you could write it as 7x to the 0 power. So a constant like 5 in this problem, we could write it as 5x to the 0 power. So technically, the 5 is a coefficient with that. We're not going to list them here, but just know that every term does have a coefficient. Okay, now it's your turn. You're going to do this last column, so pause the video, fill out the column, and come back and check in a minute. Okay, how did you do? I hope you caught all the different negative signs, especially down here for the coefficients of b cubed. Make sure you have a 1 and a -1 for these. That was probably the trickiest one on there. Okay, now we're actually going to do some problems. Notice what we have here. On the left side of this table, all the problems are being multiplied. That's stuff that you learned back in concept 10. On the right side, we're adding and subtracting, which is really just combining like terms. They're the exact same problems, the same numbers and the same variables, just different operations. Let's start on the left. For example A, 4x times 3x. Remember, you multiply your coefficients, you multiply your variables, and so we get 12x. x squared. That one should feel easy. Now let's move to the right side. When we add 4x's plus 3x's, notice how I'm saying that. I'm saying that there's 4x's there, and there's 3x's there. That should make you think, well, now there's 7x's, and that is the right way to think about that. So this answer is just 7x. It doesn't become 7x squared because we're adding them, and the only way to get x squared is to multiply x times x, which we're not doing here. So think about if you had 4x's and you add 3 more x's to that, you have a total of 7x's. That's what the answer to this one is. Let's move down to the next row. When you multiply all these together, we start by multiplying all the coefficients. So 2 times 5, that's 10. 10 times 8, that's 80. 80 times 4 is 320. And 320 times 3, that's 960. Now we need to multiply the letters together. We want to try to keep them in alphabetical order. Let's start with the j's. So j times j times j, that's going to give me j cubed. And k times k, that's k squared. That's as far as I can go with that one. Now let's look at number 2. Here we're adding instead of multiplying. So we can only add things that are like terms. Remember, like terms have to have the same variable and the same exponent. So I'm going to add my j's separately from my k's. I like to think about, when I add the j's, I like to think about some noun that starts with the letter J. How about jaguars? So I'm going to circle all the jaguars. Here I have 2 jaguars, and then I have 5 jaguars. Notice how I circled the plus sign in front of that? You should do that too. And then I have 4 jaguars. We're going to add all of them together. So if you can imagine 2 jaguars joining with 5 jaguars, at the zoo maybe, that's 7 jaguars. And now we're going to put 4 more jaguars together. That's going to give me 11 jaguars. Next, we're going to look at the K, and maybe those are kangaroos. So we have 8 kangaroos, and then we get 3 more kangaroos. So altogether, we now have 11 kangaroos. Since it's a positive 11, we use the positive sign as our connector between the terms. So we put a plus sign, and then we have our 11 kangaroos. So if you can picture that there's 11 jaguars at the zoo and 11 kangaroos at the zoo, they don't join together to become like jagaroos. They're just jaguars and kangaroos. So we can't combine these two terms any further because they're not like terms. They're unlike terms. The final answer is 11j plus 11k. All right, let's look at question 3. We're back to multiplying again. So again, we just multiply all the coefficients together. So we have 10 times 2, that's 20. 20 times 5, that's 100. And 100 times 4. So we have 400. And then m times m, that's just m squared. Now let's do the same thing but add them together. We have some terms that are just constants here and some terms that are m's. We always like to put the constants at the end. So when I take 2m, we can think of that as, say, maybe 2 monkeys. And now we have 4 monkeys. Now I have 6 monkeys. And then when we do our constants, we're just adding our constants together. So 10 plus 5 is 15. It's a positive 15. We use a plus sign as our connector, and we get 15. And they're unlike terms. We cannot combine m's with constants. So our final answer is 6m plus 15. Number 5, do the same thing with your coefficients since we're multiplying. 4 times negative 8 is negative 32. Negative 32 times 6. That's negative 192. Now multiply your x's. Remember, you can add your powers. So when we add all those exponents up there, 1 plus 2 plus 2 plus 1, that gives me x to the 6th. All I was doing there was multiplying, adding the 1 plus 2 plus 2 plus 1. That's where I got the 6 from. So the answer is negative 192, x to the 6th. On the next example, when we're adding and subtracting, I have to add the x squared terms first. So I'm going to do negative 8x squared plus 1x squared. Really, all you're doing is adding your coefficients. So negative 8 plus 1, that's negative 7x squared. I chose to do those first because you really want to have your higher powers first, if possible. It's just easier to check it with someone else if you have your higher powers first. Then we'll do the x terms. So 4x plus 6x, that's going to give me a positive 10x. Since it's positive, I use a plus sign as my connector. And I can't combine these because they're unlike terms. That's the final answer. Okay, look at the next 4 questions. They all have radicals in them. So we have to think just a little bit differently. On the left, again, we're multiplying. We multiplied radicals in concept 14. You can multiply the coefficients, and then you can multiply the radicals. So 2 times 3, that's 6. And then radical 5 times radical 5. Remember, when you multiply 2 radicals that are the same, it's really just 5. The other way to think about that was radical 5 times radical 5 is radical 25, which is, again, just 5. Either way, we get the 5, and then 6 times 5 is 30. Now for number 8, now that we're adding them together, listen to how I say this out loud. In this question, I have 2 radical 5s plus 3 radical 5s. So the way you want to think about that is, well, how many radical 5s are there? The radical 5 is like your variable. It's like their like term. Since there's 2 radical 5s and there's 3 radical 5s, that combines to make 5 radical 5s. Another way you could think about this, it's almost like when we add and subtract fractions with common denominators. If you were adding, say, a fraction of 2 twelfths plus 3 twelfths, you would get 5 twelfths. It's the same idea, but here we're adding radicals. 2 radical 5s plus 3 radical 5s is 5 radical 5s. They need to be like terms or like radicals in a way. They need to have the same radical to add them together. Number 9, we're multiplying again, and the coefficient here is 1 times 4, so we just have 4. And then radical 2 times radical 2, that's just 2. And the final answer is 8. In number 10, when we're adding them, we have 1 radical 2, and we're going to add to that 4 radical 2's, which is really just 5 radical 2's. So I have 1 radical 2 plus 4 radical 2's gives me 5 radical 2's, because they were like terms in a way. They were like radicals. That's the final answer, 5 radical 2. Okay, now these questions just get a little bit longer with a few more terms in them, but the principle still applies. We have to combine only like terms. So in number 11, we have some terms have A's, some terms have B's, and some terms have C's. We can only combine terms that have the same variables. Let's start with all the A terms. Again, I like to put some kind of a noun with it to make it make more sense. So here we have 5 apples, and then, well, somebody ate 3 apples. So now there's only 2 apples left. And then we found another apple, or we picked an apple. So now we have 3 apples. Let's move on to the B. To continue with our fruit theme, let's let the B be the bananas. So we start out with somebody ate 1 banana, and then they ate 8 more bananas, and then they ate 1 more banana. So in total, they ate 10 bananas. Since they ate them, we make that negative. We use that as our connector sign, and somebody ate 10 bananas. Finally, we'll do C, and we'll let C be cherries. So we have 1 cherry, and then we picked 5 more cherries, and so we now have 6 cherries. These 3 terms are unlike terms because they're different variables. We cannot combine them. That's our final answer. Let's go down to number 12. Here we've got some terms that have xy and some terms that have x, and those are unlike terms. Let's start with the xy terms. We have 2xy, and then we subtract 8xy. That's negative 6xy. Then we add 4 more xy, that'll be negative 2xy, and then we subtract another xy. That should be negative 3xy. Again, all we're really doing here is just adding and subtracting the coefficients. So just to review that, what we did there was we did 2, positive 2, subtract 8, that's negative 6. Negative 6 plus 4, that's negative 2. And negative 2 subtract 1 is negative 3. That's where this comes from. And then the variables just stay the same. Now let's look at our x terms. We have negative x plus 5x. That'll be positive 4x. So we use the plus sign as our connector, plus 4x. Number 13. Here we have some terms with x squared y cubes and some terms with x squared y. And they're different. We can't combine them all together. Let's start with the x squared y cube terms. So we have 2x squared y cubes, subtract 4x squared y cubes. That gives me negative 2x squared y cubed. Then we have negative 5 of these plus 4 of these, and that's going to give me negative 1. I don't need to put the 1 in the front, so it's negative x squared y. The 1 is understood. If you put it, it's not wrong, but it's just better if you don't put it there. It's simplified. All right, now look at the right side. Now we're going to do the same thing with radicals, but it's just like combining like terms. So for number 14, when we have negative 10 radical 6's plus 2 radical 6's, that's negative 8 radical 6's, then take away 5 more. That's going to be negative 13 radical 6's. Remember, the radical 6 is like your like term. It's like the variable of how many do we have, and we're just using the coefficients in the front to add them up. All right, number 15, cube roots work the exact same way. So negative 5 cube root of 9 plus 1 cube root of 9, that's negative 4. And then we're going to add 8 more. That's going to give me 4 cube roots of 9. All right, the last one. It looks like we maybe could combine all of these, but we actually can't. We have some cube roots of 7 and some square roots of 7. So let's start with the cube roots of 7. We have 4 cube roots of 7. Take away 1 cube root of 7. That's 3 cube roots of 7. And then we have 1 square root of 7 plus 5 square roots of 7. That's going to be a positive 6 square roots of 7. I cannot combine them because they're unlike terms. We have a cube root of 7 and a square root of 7, and they're different. These questions are a little bit different because sometimes you're going to have to simplify the radicals before you can combine like terms. So in number 17, we can see that we can combine the two that have radical 3's. But let's look at that radical 12. Before we do anything, let's simplify that because inside radical 12, there's a radical 4. Let's change that to radical 4, radical 3. Everything else I'm just going to copy down. I'm not going to do anything else to that. I'm going to bring down the 8 radical 3, and I'm going to bring down the 5 radical 3. So all I've done so far is simplify that radical 12. I'm going to keep going with that middle term. I'm going to change that radical 4 into a 2, and then I'm going to copy everything else down. So I have 8 radical 3 plus 2 radical 3 minus 5 radical 3. Now I can combine like terms because all of them have radical 3. So I have 8 radical 3's plus 2 radical 3's. That's 10 radical 3's. Then take away 5 radical 3's. That's going to give me 5 radical 3. Let's look at 18. Very similar, but now we have cube roots to look at. So we have 2 that have the cube roots of 2, but then there's the cube root of 16, and we can simplify that because inside the cube root of 16 is a perfect cube of 8. So I'm going to start by changing just that one. I'm going to change this to the cube root of 8 and the cube root of 2. The other parts I'm just going to copy down. So I'm bringing this down, the 4 cube root of 2 and the 6 cube root of 2. So I've just copied those parts down. Let's continue with simplifying this cube root of 8. The cube root of 8 is 2. So now I have negative 2 cube root of 2, and I'm going to bring everything else down. Plus 4 cube root of 2 plus 6 cube root of 2. Now let's add all of those up. So negative 2 cube roots of 2 plus 4, that gives me 2 cube roots of 2, and then add 6. That's going to be 8. So I have 8 cube root of 2. Again, we're just adding the coefficients. Okay, so in number 19, the first thing we should notice is that radical 20 can be simplified. What perfect square is inside of radical 20? There's a square root of 4 inside of that. Let's go ahead and simplify those. So we're going to change this to radical 4 and radical 5. And then I'm just going to copy the next two terms down. So plus radical 5 plus 3 radical 5. And then we're going to do the same thing to that radical 20. So we're going to put minus 8 radical 4 radical 5. Okay, in our next step, we're going to change that radical 4 to a regular 2 because the square root of 4 is 2. And then don't forget, we're going to multiply that by the coefficient on the outside. So right here, this is going to be a 2. The square root of 4 is 2. Multiplied by negative 2, that's going to be negative 4. And then we still have radical 5. Again, I'm just going to copy down these middle terms. So it's plus radical 5 plus 3 radical 5. And then on this last part, remember the square root of 4 is 2. And 2 times negative 8 is negative 16. So negative 16 radical 5. So finally, I'm going to take all these radical 5 terms and add and subtract the coefficients. Okay, in this last and final section, they're all mixed together. You've seen how to do all of them. So what I want you to do is to do this first 4 questions, 21 through 24, by yourself, and then check back in to see how we did. Just be careful. Pay attention when you're multiplying and when you're adding or subtracting, because the rules are very different. Go ahead and pause the video and come back when you finish these first 4 questions. Okay, how did you do with these 4? Did you notice that 23 was already simplified? There's no like terms in that question, so you can't combine anything. All right, let's move on to the next ones. Go ahead and pause the video, work on these last 4 questions, and come back and check in when you're done. Okay, take a minute and check your answers. Make sure you have correct answers written on your paper, even if you got them wrong, and then try to make sure that you understand what you did and how to fix it. Good luck on your homework tonight. Have a great day.